More about Cargo and Crates.io. So far, we've used only the most basic features of Cargo to build, run, and test our code, but it can do a lot more. In this chapter, we'll discuss some of its other more advanced features to show you how to do the following. Customize your build through release profiles. Publish libraries on Crates.io. Organize large projects with workspaces. Install binaries from Crates.io. And extend Cargo using custom commands. Cargo can do even more than what we cover in this chapter, so for a full explanation of all its features, see its documentation. Customizing builds with release profiles. In Rust, release profiles are predefined and customizable profiles with different configurations that allow a programmer to have more control over various options for compiling code. Each profile is configured independently of the others. Cargo has two main profiles: the dev profile file Cargo uses when you run cargo build, and the release profile Cargo uses when you run cargo build flag release. The dev profile is defined with good defaults for development, and the release profile has good defaults for release builds. These profile names might be familiar from the output of your builds. So we've got finished dev, unoptimized plus debug info, and then cargo build release, finished release, optimized. The dev and release shown in this build output indicate that the compiler is using different profiles. Cargo has default settings for each of the profiles that apply when there aren't any profile.glob sections in the project's cargo.toml file. By adding profile sections for any profile you want to customize, you can override any subset of the default settings. For example, here are the default values for the opt level setting for the dev and release profiles. Profile.dev opt level equals 0. Profile.release opt level equals 3. The opt level setting controls the number of optimizations Rust will apply to your code with a range of 0 to 3. Applying more optimizations extends compiling time, so if you're in development and compiling your code often, you'll want faster compiling even if the resulting code runs slower. That's why the default opt level for dev is 0. When you're ready to release your code, it's best to spend more time compiling. You'll only compile in release mode once, but you'll run the compiled programs many times. So release mode trades longer compile time for code that runs faster. And that's why the default opt level for the release profile is 3. You can override any default setting by adding a different value for it in cargo.toml. For example, if we want to use optimization level 1 in the dev profile, we can add these two lines to our project's cargo.toml file. Profile.dev opt level equals 1. This code overrides the default setting of 0. Now, when we run cargo build, Cargo will use the defaults for the dev profile plus our customization to opt level. Because we set opt level to 1, Cargo will apply more optimizations than the default, but not as many as in a release build. For the full list of configuration options and defaults for each profile, see Cargo's documentation. Publishing a crate to Crates.io. We've used packages from Crates.io as dependencies of our project, but you can also share your code with other people by publishing your own packages. The Crate registry at Crates.io distributes the source code of your packages, so it primarily hosts code that is open source. Rust and Cargo have features that help make your published package easier for people to use and to find in the first place. We'll talk about some of these features next and then explain how to publish a package. Making useful documentation comments. Accurately documenting your packages will help other users know how and when to use them, so it's worth investing the time to write documentation. In Chapter 3, we discussed how to comment Rust code using 2 slashes. Rust also has a particular kind of comment for documentation, known conveniently as a documentation comment, that will generate HTML documentation. The HTML displays the contents of the documentation comments for public API items intended for programmers interested in knowing how to use your crate, as opposed to how your crate is implemented. Documentation comments use 3 slashes instead of 2, and support markdown notation for formatting the text. Place documentation comments just before the item they're documenting. Listing 14.1 shows documentation comments for an add1 function in a crate named myCrate. Listing 14.1, a documentation comment for a function. Here we give a description of what the add1 function does. Start a section with the heading examples, and then provide code that demonstrates how to use the add1 function. We can generate the HTML documentation from this documentation comment by running cargo doc. This command runs the rustdoc tool distributed with Rust and puts the generated HTML documentation in the target/doc directory. For convenience, running cargo.flagOpen will build the HTML for your current crate's documentation, as well as the documentation for all of your crate's dependencies, and open the result in a web browser. Navigate to the add1 function and you'll see how the text in the documentation comments is rendered, as shown in figure 14.1. Oh crap, I didn't pause the recording. Well anyway, I just couldn't help but notice that this is figure 14.1 and this is, listing 14.1. Just kidding. Yeah, okay. Commonly used sections. We used the #examples markdown heading in listing 14.1 to create a section in the HTML with the title examples. Here are some other sections that crate authors commonly use in their documentation. Panics, errors, safety. Panics, the scenarios in which the function being documented could panic. Callers of the function who don't want their programs to panic should make sure they don't call the function in these situations. Errors. If the function returns a result describing the kinds of errors that might occur and what conditions might cause those errors to be returned, can be helpful to callers so they can write code to handle the different kinds of errors in different ways. Safety. If the function is unsafe to call, we discuss unsafety in Chapter 19. There should be a section explaining why the function is unsafe and covering the invariants that the function expects callers to uphold. Most documentation comments don't need all of these sections, but this is a good checklist to remind you of the aspects of your code that people calling your code will be interested in knowing about. Documentation comments as tests. Adding example code blocks in your documentation comments can help demonstrate how to use your library, and doing so has an additional bonus. Running cargo test will run the code examples in your documentation as tests. Nothing is better than documentation with examples, but nothing is worse than examples that don't work because the code has changed since the documentation was written. If we run cargo test with the documentation for the add1 function from listing 14.1, we will see a section in the test results like this. Doc tests myCrate running one test. Yep. Now if we change either the function or the example so that the assert equals in the example panics and run cargo test again, we will see that the doc tests catch that the example and the code are out of sync with each other. Commenting contained items. Another style of doc comment, /bang, adds documentation to the item that contains the comments rather than adding documentation to the items following the comments. We typically use these doc comments inside the crate root file, lib by convention, or inside a module to document the crate or the module as a whole. For example, if we want to add documentation that describes the purpose of the myCrate crate that contains the add1 function, we can add documentation comments that start with /bang to the beginning of the lib file, as shown in listing 14.2. Notice there isn't any code after the last line that begins with /bang. Because we started the comments with /bang instead of 3 slashes, we're documenting the item that contains this comment rather than an item that follows this comment. In this case, the item that contains this comment is the lib file, which is the crate root. These comments describe the entire crate. When we run cargo doc open, these comments will display on the front page of the documentation for myCrate above the list of public items in the crate, as shown in figure 14.2. Figure 14.2 rendered documentation for myCrate, including the comment describing the crate as a whole. Documentation comments within items are useful for describing crates and modules especially. Use them to explain the overall purpose of the container to help your users understand the crate's organization. Exporting a convenient public API with pub/use. In Chapter 7, we covered how to organize our code into modules using the mod keyword, how to make items public using the pub keyword, and how to bring items into scope with the use keyword. But the structure that makes sense to you while you're developing a crate might not be very convenient for your users. You might want to organize your structs in a hierarchy containing multiple levels, but then people who want to use a type you've defined deep in the hierarchy might have trouble finding out that type exists. They might also be annoyed at having to enter use, myCrate, some module, another module, useful type, rather than use myCrate useful type. The structure of your public API is a major consideration when publishing a crate. People who use your crate are less familiar with the structure than you are and might have difficulty finding the pieces they want to use if your crate has a large module hierarchy. The good news is that if the structure isn't convenient for others to use from another library, you don't have to rearrange your internal organization. Instead, you can re-export items to make a public structure that's different from your private structure by using pub/use. Re-exporting takes a public item in one function and makes it public in another location. Yeah, a public item in one location and makes it public in another location, as if it were defined in the other location instead. For example, say we made a library named Art for modeling artistic concepts. Within this library are two modules, a kinds module containing two enums named primary color and secondary color, and a utils model containing a function named mix, as shown in listing 14.3. /bang hash art new line, a library for modeling artistic concepts. PubMod kinds, 3 slashes. The primary colors according to the RYB color model. Pub enum primary color, red, yellow, blue. Dot comment, the secondary colors according to the RYB color model. Pub enum, secondary color, orange, green, purple. PubMod utils, use crate kinds glob. Dot comment, combines 2 primary colors in equal amounts to create a secondary color. Pub function mix takes C1 primary color and C2 primary color and returns secondary color. Figure 14.3 shows what the front page of the documentation for this crate generated by Cargo Doc would look like. Figure 14.3, front page for the documentation for art that lists the kinds and utils modules. Note that the primary color and secondary color types aren't listed on the front page, nor is the mix function. We have to click kinds and utils to see them. Another crate that depends on this library would need use statements that bring the items from art into scope, specifying the module structure that's currently defined. Listing 14.4 shows an example of a crate that uses the primary color and mix items from the art crate. In main, use art kinds primary color, use art utils mix. Main function, let red equal primary color red. Let yellow equal primary color yellow, mix red, yellow. The author of the code in listing 14.4, which uses the art crate, had to figure out that primary color is in the kinds module and mix is in the utils module. The module structure of the art crate is more relevant to developers working on the art crate than to developers using the art crate. The internal structure that organizes parts of the crate into the kinds module and the utils module doesn't contain any useful information for someone trying to understand how to use the art crate. Instead, the art crate's module structure causes confusion because developers have to figure out where to look. And the structure is inconvenient because developers must specify the module names in the use statements. To remove the internal organization from the public API, we can modify the art crate code in listing 14.3 to add pub use statements to re-export the items at the top level, as shown in listing 14.5. Pub use, self, kinds, primary color. Pub use, self, kinds, secondary color. Pub use, self, utils mix. PubMod kinds, snip, PubMod utils, snip. The API documentation that Cargo Doc generates for this crate will now list and link re-exports on the front page as shown in figure 14.4, making the primary color and secondary color types and the mix function easier to find. Figure 14.4, the front page of the documentation for art that lists the re-exports. The art crate users can still see and use the internal structure from listing 14.3 as demonstrated in listing 14.4, or they can use the more convenient structure in listing 14.5 as shown in listing 14.6. Use art primary color, use art mix. In cases where there are many nested modules, re-exporting the types at the top level with a pub use can make a significant difference in the experience of people who use the crate. Creating a useful public API structure is more of an art than a science, and you can iterate to find the API that works best for your users. Choosing pub use gives you flexibility in how you structure your crate internally and decouples that internal structure from what you present to your users. Look at some of the code of crates you've installed to see if their internal structure differs from their public API. Setting up a Crates.io account. Before you can publish any crates, you need to create an account on Crates.io and get an API token. To do so, visit the home page at Crates.io and log in via a GitHub account. The GitHub account is currently a requirement, but the site might support other ways of creating an account in the future. Once you're logged in, visit your account settings at Crates.io/me and retrieve your API key. Then run the cargo login command with your API key like this. Cargo login, ABCD, all that. This command will inform Cargo of your API token and store it locally in Cargo in home/.cargo/credentials. Notice that this token is a secret. Do not share it with anyone else. If you do share it with anyone for any reason, you should revoke it and generate a new token on Crates.io. Adding metadata to a new crate. Now that you have an account, let's say you have a crate you want to publish. Before publishing, you'll need to add some metadata to your crate by adding it to the package section of the crate's cargo.toml file. Your crate will need a unique name. While you are working on a crate locally, you can name a crate whatever you'd like. But crate names on Crates.io are allocated on a first-come, first-served basis. Once a crate name is taken, no one else can publish a crate with that name. Before attempting to publish a crate, search for the name you want to use on the site. If the name has been used by another crate, you'll need to find another name and edit the name field in the cargo toml file under the package section to use the new name for publishing, like so. Package name equals guessing_game. Even if you've chosen a unique name, when you run cargo publish to publish the crate at this point, you'll get a warning and then an error. Cargo publish snip error API errors missing or empty metadata fields description license. The reason is that you're missing some crucial information. A description and license are required so people will know what your crate does and under what terms they can use it. To rectify this error, you need to include this information in the cargo toml file. Add a description that is just a sentence or two, because it will appear with your crate in search results. For the license field, you need to give a license identifier value. The Linux Foundation Software Package Data Exchange lists the identifiers you can use for this value. For example, to specify that you've licensed your crate using the MIT license, add the MIT identifier. So package license equals MIT. If you want to use a license that doesn't appear in the SPDX, you need to place the text of that license in a file, include the file in your project, and then use license file to specify the name of that file instead of using the license key. Guidance regarding which license is appropriate for your project is beyond the scope of this book. Many people in the Rust community license their projects the same way as Rust, by using a dual license of MIT or Apache 2. This practice demonstrates that you can also specify multiple license identifiers separated by OR to have multiple licenses for your project. With a unique name, the version, the author details that Cargo knew added when you created the crate, your description, and a license added, the Cargo toml file for a project that is ready to publish might look like this. Package, name, version, authors, edition, description. A fun game where you guess what number the computer has chosen. License, dependencies. Cargo's documentation describes other metadata you can specify to ensure others can discover and use your crate more easily. Publishing to Crates.io. Now that you've created an account, saved your API token, chosen a name for your crate, and specified the required metadata, you are ready to publish. Publishing a crate uploads a specific version to Crates.io for others to use. Be careful when publishing a crate because a publish is permanent. The version can never be overwritten and the code cannot be deleted. One major goal of Crates.io is to act as a permanent archive of code so that builds of all projects that depend on crates from Crates.io will continue to work. Allowing version deletions would make fulfilling that goal impossible. But there are no limit to the number of crate versions you can publish. Run the cargo publish command again. It should succeed now. Congratulations! You have now shared your code with the Rust community and anyone can easily add your crate as a dependency of their project. Publishing a new version of an existing crate. When you've made changes to your crate and you're ready to release a new version, you change the version value specified in your cargo toml file and republish. Use the semantic versioning rules to decide what an appropriate next version number is based on the kinds of changes you've made. Then run cargo publish to upload the new version. Removing versions from Crates.io with cargo yank. Although you can't remove previous versions of a crate, you can prevent any future projects from adding them as a new dependency. This is useful when a crate version is broken for one reason or another. In such situations, Cargo supports yanking a crate version. Yanking a version prevents new projects from starting to depend on that version while allowing all existing projects that depend on it to continue to download and depend on that version. Essentially, a yank means that all projects with a cargo lock will not break, and any future cargo lock files generated will not use the yanked version. To yank a version of a crate, run cargo yank and specify which version you want to yank. Cargo yank flag vers 1.0.1. By adding undo to the command, you can also undo a yank and allow projects to start depending on a version again. A yank does not delete any code. For example, the yank feature is not intended for deleting accidentally uploaded secrets. If that happens, you must reset those secrets immediately.